Good day, ladies and gentlemen. My name is Herald and Saavedra, your host for today. For today's topic, we're gonna be talking all about geotechnical engineering. But first and foremost, let's dive right into its brief history. The history of geotechnical engineering is long and quite interesting. Our ancestors, back in the olden days, used soil for an extensive variety of activities, from buildings and creation of construction materials to irrigation and flood control. However, the earliest applications were not very much advanced. It was simply related to flood control as well as irrigation, as exhibited by traces of dikes, dams, and canals that have been discovered in some parts of ancient Egypt, Greece, and other parts of the world dating back to not less than 2000 BCE, or also known as before Christ era. As these areas developed, the construction of structures which were supported by formalized foundations began. For instance, the people of Greece notably built pad footings as well as strip and raft foundations during this time. However, the science of soil design was still a non-existing phenomenon. By the 18th century, as civilization advanced further, numerous engineering problems related to building foundations began to emerge. The Leaning Tower of Pisa, which is a tourist attraction today for example, presented a very unique challenge at that time. What happened is that the tower had been constructed on a soft ground composed mostly of clay, fine sand, and shells without using enough stones to make a strong foundation. Due to the heavy weight without enough base support, the structure had no option but to sink a little bit into the earth. One side happened to go further deeper into the ground than the other, causing the tower to lean to one side. The Leaning Tower of Pisa actually makes an important part of the history of geotechnical engineering. The Leaning Tower experience is what prompted engineers to start taking a more scientific approach, setting up foundation of buildings with respect to soil design and structure. Significant soil theories guiding the construction of building foundation began to emerge. A French engineer by the name of Henry, also known as Hubert Gautier, recognized natural slope of different soils, an idea which later on developed into something known as soil's angle of repose. And then more principle of soil mechanics came into existence. Next to present is no other than Miss Irene Romero. Miss Irene, please take over.
Geotechnical engineering, also known as geotechnics, is the branch of civil engineering concerned with the engineering behavior of earth materials. It uses the principles of soil and rock mechanics for the solution of its respective engineering problems. It also relies on knowledge of hydrology, geology, geophysics, and other related sciences. Geotechnical engineering utilizes the disciplines of soil and rock mechanics to investigate subsurface and geologic conditions. These investigations are used to design, build foundations, earth structures, and pavement subgrades. People in the geotechnical engineering field deal with structures such as tunnels, bridges, roads, railways, and more. Geotechnical engineers deal with a different type of ground for every project. Whether it's made out of soil or rock, it is the job of geotechnical engineers to figure out how it will interact with the project. This excites most geotechnical engineers because no two grounds are the same.
Thank you for that wonderful information, Miss Irene. Up next is our very own Miss Caryl Historia.
Importance of geotechnical engineer. Soil engineer or soil mechanics is one of the younger disciplines of civil engineering. involving the study of soil, its behavior, and its application. As an engineering material, the term soil engineering is currently used to cover a much wider scope, implying that it is a practical science rather than a purely fundamental or mathematical one. Good soil engineering embodies the use of best practices and exploration, testing, design, and construction control in addition to accepted theories. In earlier times, buildings were constructed on certain assumptions about the soil conditions, and the builders themselves decided on the type of foundation for any structure. After some notorious foundation-related engineering problems, most importantly the Leaning Tower of Pisa, builders and researchers across the globe were prompted to shift to a more scientific approach that examines the subsurface. It is a practice that relates to the engineering behavior of the earth and its materials. As a branch of civil engineering, it is of great importance to construction activities taking place on the surface or within the ground, as well as to mining, coastal drilling, and other disciplines. Despite having considerable overlap, geotechnical engineering differs from engineering geology in that it is a specialty of engineering, whereas the latter is a specialty of geology. Geotechnical engineers are responsible for evaluating subsurface and soil conditions and materials, using the principles of soil and rock mechanics. They are commonly appointed as consultants on construction projects. Engineers also examine environmental issues such as flood plains and water tables. By doing so, they are able to determine whether a particular site is suitable for a proposed project and can inform the engineering design process with regard on how ground conditions can be made safe and effective for construction.
Thank you for that informative data, Miss Caryl. Up next is no other than Miss Rachelle Sabuero.
Is geotechnical engineering a good career? Geotechnical engineers' job prospects are good, and you can expect better than average job security. According to the Bureau of Labor Statistics, the job industry for geotechnical engineer is expected to see growth of around 11% over the next decade or so, which is higher than the average job growth rate, then which assures that geotechnical engineering is a good career and will give rise to the great career opportunities for civil engineering graduates.
Thank you for that splendid explanation, Miss Rachel. Up next is our very charming and handsome Mr. J.C. Guadayo.
Geotechnical engineering as we know it now began in 1925. In the early 20th century, the Austrian Carl von Terzaghi was a mechanical engineer, geotechnical engineer, and a geologist recognized as the father of soil mechanics and geotechnical engineering. His first job was as a junior design engineer and later on became a professor. He was an outstanding geotechnical engineering professor of his time, with regular positions first in Istanbul, then at MIT, Vienna, and Harvard. Carl Terzaghi was the first to elaborate a comprehensive mechanics of soils with his publication of Erdbaumechanik in 1925. His most significant contribution was his recognition and development of the effective stress principle and its impact on settlement analysis, strength, permeability, and erosion of soils.
Thank you for that banging information you have, Mr. JC. Up next, but not very least, Miss Nolyn Retiza. Miss Nolyn, please take over.
Now that we know what geotechnical engineering means, also known as geotechnics, which is a branch of civil engineering concerned with the engineering behavior of earth materials. The specialism involves using scientific methods and principles of engineering to collect and interpret the physical properties of the ground for use in building and construction. Now let us know the three branches of geotechnical engineering: soil mechanics, rock mechanics, and foundation engineering. First, we have soil mechanics. It involves the engineering mechanics and properties of the soils. Same as the second one, the rock mechanics, which also involves engineering mechanics and properties of rocks. Both applies the basic principles of mechanics, including kinematics, dynamics, fluid mechanics, and mechanics of materials. Mechanics is the physical science that treats the action of forces on bodies in order to build with or on soil or rock. The properties and behavior of the soil or rock must be known. The third one, we have foundation engineering. Foundation engineering applies geology, soil mechanics, rock mechanics, and structural engineering to the design and construction of foundations for civil engineering and other structures. Must be able to predict performance or response foundation soil or rocks to load imposed by the structure. Primary considerations of any constructed facility is performance, economy, and safety. Geotechnical engineers design foundations based on the load characteristics of the structures and the properties of the soils and or bedrock at the site.
And that, ladies and gentlemen, sums up our whole presentation. Again, my name is Herald, and I'll be seeing you soon. Take care.